In this video, we're going to look at how to simplify a radical of a radical. That sounds kind of crazy. Let me give you an example of what I'm talking about. Let's say I wanted to do the square root of the cubed root of 5. Right? How do I simplify that and write that as a simple one radical expression? Right? That's kind of craziness over there. So we're going to use a few rules to help us simplify this. And the first rule is changing things to fractional exponents. Okay, so let's say I have a radical like this, the nth root of x to the m. How do I write that as x to a power? You got that rule? We need to have that rule. It's m over n, right? That's how I change it. So whatever's the index becomes the denominator of the exponent. And if there's a power here, if not as 1, but there's some power, that's going to become the numerator of the exponent. So what we're going to do first is we're just going to look at what's underneath here, okay? So I'm going to write the square root. I'm going to leave that. And now, how do I change this cubed root of 5 into a fractional exponent? That's 5 to what power? 5 to what power? You got it? 5 to the third. Okay, good. Now, a square root. Now we're going to deal with the square root. Let me rewrite this without the shading here. 5 to the third. How could I write 5 to the third to a power? So now we're looking at the square root. So the square root is what power? What power would that be? The square root would be to the half, right? Because there's a 2 here. So that's a half power. The square root is always a 1/2 power, right? So if I come over, I could write a rule for that. I could say the square root of x, it would be sort of a sub-rule of this. There's a 2 written here. There's a 2, silent 2, an invisible 2. So that's going to be my denominator. And then x doesn't have an exponent written, so we know that that is to the first power. If it's not written, it's to the first power. So the square root of anything is that thing to the 1/2 power. All right, next rule. Now, what do I do when I have these two together, these two exponents here? So we have the rule x to the n to the mth. What do I do with these two exponents? You got to know these rules. I got to multiply those exponents together. So to simplify this, I'm going to take 5 to the third times 5 to the half. And a third times a half is a sixth. And then I can rewrite this back in radical form as the sixth root of 5. And again, we could check this on our calculator. We could type in the square root of, this is going to be kind of crazy, I'm going to type this in, the square root of the fifth root of 5, the square root of the cubed root of 5. So under that square root, I'm going to put the cubed root of 5. So there's the decimal approximation for the square root of the cubed root of 5 right there. And then I could type in the sixth root of 5. So 6, math, option 5, the sixth root of 5. And we get the same exact decimal approximation. So we know that those are equivalent. And certainly you would agree the sixth root of 5 is much simpler than the square root of the cubed root of 5. Now, another example might not have numbers as the radicand. We might have variables in there. So let's try simplifying the fourth root of the cubed root of x to the 7th. All right, so the first thing we want to do is deal with what's under here. We just want to write this part as a fractional exponent. So we're just going to bring the fourth root down and write the cubed root of x to the 7th as x to some power. Maybe you want to pause the video and try this and see if you can finish it. If you feel confident, just finish the whole thing. All right, so hopefully you wrote this part as x to the 7 over 3. Great. So now I have x to the 7 over 3, and now I need to change the fourth root to an exponent and put that up here. So the fourth root would be to the 1/4 power. Now I multiply these exponents. So 7/3 times 1/4 is 7/12. And then I can rewrite that back in radical form as the 12th root of x to the 7th. And that would be it. Now you might be seeing a pattern here, which you certainly can use carefully. This index and this index are getting multiplied together to give that index. And why is that? Why is that happening? Well, it's because we're multiplying these fractions together, and when you multiply fractions, you multiply the denominators. And these indexes become the denominator when you write these in fraction form. So certainly you could use that shortcut to help you work through these a little bit faster now that you understand why we would multiply those together.